Hello everyone. Today Avinash and I are going to present on urban heat island mapping. Here's a quick overview. First, we will define urban heat island and state our objectives. Second, we will discuss previous research and some of the pros and cons. Third, we will offer three solutions to meet objectives and explain how our solutions address the cons in previous research. Finally, we will examine how our solution contribute to the society good. In, so the objective of this presentation is to develop a more efficient and accurate way to collect air temperature across the city, in this case Richmond. So why would we want to collect the air temperature? Because air temperature reflects the condition in which people are living in and can affect quality of life. Within the urban, there are areas concentrated with concrete structures and thus have a higher temperature than outlying areas. These hotspots are called urban heat islands. One of the previous research is done by Dr. Fong and his colleagues. In his research, 20 teams of volunteers rode, biked, and walked across Richmond City to collect the temperature using handmade sensors. This approach, although cheap, relies heavily on the labor force. Another approach is done in Wisconsin. In this Wisconsin research, permanent temperature sensors are used. This approach, although does not rely heavily on labor, is very expensive. As we can see, the cost of a 150 sensor is about 40,000. That's not good. We want a solution that can offer both cost efficiency and minimum labor. The first solution our team proposed is to use the microcontroller Arduino coupled with a software, such as Raspberry Pi, MATLAB, or Python, to automate the collection of air temperature. As we can see, for a 150 sensor, our approach only costs 3,400 as opposed to $37,000 of the Wisconsin research. That's one-tenth of the cost. Plus, our approach only requires labor at the installment stage, hence meeting the requirement of the reduced labor. To further reduce our costs, our team proposed a second solution to minimize the number of sensors needed while maintaining some confidence with the inference of our metrics. We utilize k-mean clustering to find the optimum value of k, a number of clusters, that can group similar temperature areas within a city. Furthermore, we can use historical events and features to predict the hottest, coolest area within a city and mitigate these extremities. Next, Avinash will show you the code that links Arduino and MATLAB. Then he will talk about our third solution to the problem. Go.